Hi, Professor. My project is traffic transportation clustering using infinity propagation on PY Spark. So, what is traffic transportation? More and more cars are made by factories, and as a result, more and more cars appear on the roads. For example, if a traffic jam will happen in street A, we need to analyze how much bad influence on the other roads and give a driver some good idea to avoid those streets that's similar to street A. So in other words, we need gathering some points as a cluster if they are in similar attribute. So what is clustering? The main area is data analyzed. Give a big data set. The elements are partitioned sent into several clusters, and data elements in the same cluster are likely each other. In other words, data elements in different are dissimilar. So, what algorithms are used for clustering? For the clustering algorithm is one of fundamental techniques in the data mining, such as k-mean, anti-colony optimization, and infinite propagation. So those algorithms play a crucial role in various applications such as pattern recognition, document retrieval, and computer version. What is different between infinite propagation and k-mean? The infinite propagation is required no parameter indicate the number of clusters. That is the main different points. So what is the infinite propagation? That means all points can be potential centers. It determines the cluster center by passing message between data points. So we don't need initialize the number of cluster. So there are two main message transfer between data points. One is responsibility. The data point I will send message to candidate examiner K, indicate how appropriate the point K as the examiner. So the other message is called availability. So that means candidate center K will send a message to data point I, indicate how properly for data point I and identify the point K as the examiner. What is the formula? The first one is responsibility. The similarly I to K means how well the data point K is suitable to be the center for the data point I. So the next thing is availability. On the picture side, how to communicate between those data points. So by updating those messages intervally, the algorithm could automatically determine the number of clusters and which point should be identified as the center. After iteration, each point determined its own examiner by combining those two metrics. For point I, the point K will be determined as the center of point I if availability I to K and responsibility I to K is maximum. So I will introduce how to use infinite propagation on the Spark. So firstly, I will introduce what is a MapReduce. So MapReduce is a designable solution where we need to handle large scalar dataset. It looks like a parallel programming model. It can execute the data points more efficiently. So user can define the map and reduce by themselves and execute automatically. It can be provide a series of functions such as faulty tolerance, data assignment, and data storage. So MapReduce is run a distributed file system. So Spark is a fast and generate energy for large-scale data processing. It is also a realization of the MapReduce framework. So why I use the Python Spark? To compare Hadoop MapReduce, the Spark use resilient distributed dataset to realization the in-memory computing technique, which provide a better optimization than Hadoop. The data in RAM in the Spark instead of slowly disk driven. The MapReduce is present the full dataset to Hadoop distributed file system after running each job, so that is very expensive. So from the paper, I found one Python Spark implementation of infinite propagation clustering. The paper used infinite propagation twice, and it will waste a lot of time, since the time complexity of infinite propagation is t times n squared, where t is the max iteration. It is a parameter for the infinite propagation. So instead of that, I just use one map and two reducer. So firstly, we need to get initial similarity by using calculating the distance between each point and choosing a property preference value. The second one, we need divided input data into small pieces randomly and put them into resilient distributed dataset. So in the Python Spark system, we need to assign tasks to the mapper, and each mapper get different divided data from resilient distributed dataset and run the infinite propagation on their own data parallelly. The thirdly, the reduce will calculate all the result, and if the distance of two centers is less than the standard, the points will regularly into 2 points will combine to in one cluster. So reduce B will calculate the final center for each cluster. And since each cluster will have multiple centers, the final center will be the average of multiple centers. The formula is centroid is equal to C1 plus 2CK divided K. So in the final, each point will get a new center in the cluster. So for the experiment framework, the program development and experiment are complete on a Mac. So I use Python Spark 2.3.7 and also installed Google Cloud SDK. The Java version is 30.0.2 and Python version is 3.7. So I have 6 experiments. The first 3 of them is compared worker and sequential. So for the result, we can see from experiment 1 to experiment 3, when we increase the worker, they will decrease the extension time. Since each worker can do the task in the parallel, it will increase work efficiency. And for the experiment 4 to 6, when we increase the iteration, the the number of cluster will increase, but when we increase the number of iteration continually, the number of cluster will not change, and the execution time will also increase, since the final result has been satisfied the max iteration. So for example, for some data points, the best result of the iteration is 40, but we have the maximum iteration is 100. So it will waste a lot of time from 15 iteration to 100 iteration. So and the result is will also not change, since after 40 iteration the result is the same for each iteration. So for the other experiment, we will see when the value of preference is increased, the number of cluster is also increased, since the preference can determine the number of cluster, and if you choose a smaller number, it will get a smaller value of the cluster. So for the conclusion and the future, for the conclusion, I will talk about 3 things. So the first one is if we increase the map, it will increase work efficiency. That means it will decrease the execution time. So when you increase the preference, it will increase the number of cluster. So Python Spark will not change the clustering result when the result satisfies the best result. And if you have a big iteration, it will waste a lot of time. But the result will not change because it is satisfied the best result. So in the future, I will explore some advanced algorithm to implement the infinite propagation clustering in dynamic environment. Since this experiment, the environment is statistic in this project, so I will do some experiment in the dynamic environment in the future. I will also explore the relationship between the result of cluster and preference. The last things, I will explore some parallel algorithm design if communication among the map become possible. So I have read some paper taught me that we can combine parallel algorithm with the Python Spark. So I will do some experiment for that. So that is my project. Thank you for your kindness care in this term. Please take care.